Okay, so we start with the statement that the absolute value of x minus 7 is less than 5. And people tell me that first 7 is a solution, certainly 7 minus 7 is 0, and that's less than 5. And then everybody's pretty clear in the idea that all the integers up through 11 give you results that are less than 5, right? Okay? But 12, no, because absolute value 12 minus 7 is 5, and it's not less than 5, right? So we're off to a pretty good start. So we could even draw a number line here. Let's see, we've got 7 up through 11. And of course there's 8, 9, and 10 in there, right? So these are all solutions. Okay, so every integer from here to here is a solution, right? Any other integers that are solutions?
Could you do like 6 and 5 and do negative numbers?
Yeah, well, 6 is a solution, isn't it? Somebody tell me what 6 minus 7 is.
Negative 1.
Negative 1. What's the absolute value of negative 1?
1.
1. Okay? So I'll say 6 is also a solution. Since absolute value is 6 minus 7 is the absolute value negative 1, which is 1, and 1 is less than 5, isn't it? Okay? So we can now include 6. Okay? And, you know, Sarah said 5. I believe her. And, yeah, clearly 5 is a solution because 5 minus 7 is negative 2, and absolute value is 2, and that's less than 5, right? Okay? And it's also true for 4 and 3. Right? Okay, check it out. You know, just be sure. 3 minus 7 is negative 4. Absolute value is 4. That's less than 5. Okay? So we're good with this? But not not 2. And I won't detail that, but you know, you're going to get 5 and it's not less than 5, right? Now if the inequality was less than or equal to 5, then 12 would be a solution, and so would 2, right? Okay? So I can actually go as far as 12, but put a circle around it to indicate that it's not included, right? And I could go to negative 2 and put a circle around it to show that it's not included, right? Well, 7 is kind of in the middle here, isn't it? So, at least from here to here, all integers that are within 5 units of 7, right? And then I'll say non-inclusive, meaning that if they are 5 units from 7, we're not going to include them, right? And you notice we go 5 units from 7, we get 12, right? We go 5 units this way, we get, I don't know why I put a negative in that, but 2, right? Okay? Make sense? So what this is really saying is I'll say x is within 5 units of 7, non-inclusive because we don't include being at 5 units. Right? That make sense? Should be fairly clear. And if it isn't, you want to ponder it a little bit. Your book tells you the same thing. Okay? And practically any pre-calculus book will tell you the same. Now, I didn't say anything about integer solutions, did I? Okay? So, I'm going to say that any number that's between 7 and 12, not equal to 12, is going to be a solution, isn't it? Because it's not till we get to 12 that we find a number that makes this false, right? So if we go from 7 all the way up to 12, the first number that gives us 5, which we don't include, is 12. So anything up to 12 is included, right? So non-integer solutions, in other words, real number solutions, go from here to here, still non-inclusive, right? Okay? And they also go from here to here, non-inclusive. And I'm going to say that's the interval from -2 to 12. And it's not -2. I don't know what's the matter. It's the minus that I keep focusing on. So the real number solutions are x values in the interval from 2 to 12, right? Okay? And we would actually write that out officially as the set of x such that x is in the interval from 2 to 12, and that's something you want to ponder a little bit and get used to. Okay? Make sense? I mean, yeah, that notation, set builder notation, you're supposed to have seen that quite a bit by now, but probably haven't. And it's, you know, it's a little hard to understand. I had to look at it a few times when I encountered it in high school. It wasn't immediately obvious why in the world we'd write it that way, but that's the way we write it. And it becomes obvious if you think about it. Okay, so anyhow, that's a solution to this inequality.